Hello, my name is Nikolai and I am the segment product manager for wine and beer. Today we are here to talk about the BeerFoss GO, Foss's beer instrument. It is our new venture into beer again. We've been there before, now we're back. And this instrument is targeted towards the craft breweries at a certain size. So it's craft breweries that deliver to some sort of retail store, supermarket, or to a large customer group. This instrument runs on, as the FT indicates, it runs on an FTIR technology. And today I will walk you through how it measures, how the measuring chain works, what sort of accessories we need to actually measure, what the output is, and a bit about the competitive advantages of this instrument. So, the BeerFoss GO works by sucking up through the pipette, and then we have a piston that it uses to push the beer into our interferometer. And this is relevant because we're using an FTIR technology, which is quite known to Foss. We have it in wine and dairy already, but now we are also using it for beer. So it's a quite trusted and known technology for Foss. Now I'll show you how we actually measure. So for measuring, you would normally in a context filter and degas your beer. For this instrument, let's say we have a sample directly from our fermentation vessel. You would just pour that into our sample cup. And then instead of filtering and degassing and everything, we just directly add our filter into this, press it down, and now you have a filtered sample. And this you can add directly to the pipette. Whoop. Then you go over here, you choose what you actually want to measure, in this case fermentation, and then you can just press go. I'll just show you another sample that we're actually going to run, which is directly from the can. This is a finished product. It's a finished Pilsner beer. We just add that directly to the pipette like this. You go in here, you choose beer, and then we press go. And now we're actually running. So as you can see, we're dragging in through the pipette and into the piston. And this piston here is actually functioning, as you can see, the small bubbles here. It's actually functioning a bit like pouring a beer. And I'll show you that now. So, this is how a normal degassing procedure for measuring a brewery would go. You would pour your beer, get as much CO2 out of it as possible. You can see you have a lot of foam. And what we are actually doing is pouring really slowly down the side. That's the gentle suction of the piston and pushing into the interferometer. And there's quite a bit of foam difference, as you can see. This is important because inside of the instrument we have the interferometer and we have a cuvette that we are pushing the sample into. And if we have bubbles inside of here, then we can't actually measure. So what we are doing is making it super gentle, so you encapsulate the CO2 inside of the sample, and that actually enables us to measure directly on the liquid without degassing. Now here in a second we'll get a lot of values, and I can walk you through what the different parameters actually add a value for our customers. For the finished beer, the most important parameter is the alcohol. And this is also why we use an FTIR technology, because alcohol you can measure directly in the FTIR spectrum. And in a normal brewery, the way you measure is based on density, and it's density in water. But the moment you have alcohol during a fermentation, then your measurements will actually be slightly off. And this is a big problem in the craft brewing industry because you don't get the right numbers. Alcohol is important from our customers because of a tax point of view and also because of other regulations. So when they export or they sell in their internal countries, they of course put a little mark on the brand that says, let's take this for example, 4.8. So this is the declaration of alcohol for this beer. So if they, for a tax group, don't actually hit that measurement, then they can get fines, and they also differentiate between how much are they actually paying to the state for producing this beer. Two other parameters from a quality control point of view is the density, which is the amount of sugars, and then we have the pH, which is a process control for how is the beer doing during fermentation, and how stable is it during the final product. So you know where your beer is going to turn out, and if it doesn't turn out at this pH, for example, then you know something is wrong. So these are the different parameters. We have 8 different ones of them, and as I said, the really important one is alcohol, and then we have sugars and pH. Let's say we are now done measuring. You just slide off this one, and we want to clean it for either maintenance purposes or just a daily cleaning routine. The first thing you'll do is just press this small logo down here with the droplet. That's a clean. And now the instrument is cleaning itself. Then to clean the outside of the pipette, I just grab a small piece of cloth and do it like this, and it's clean. And that's actually everything from a cleaning point of view. Just to talk through the two main value propositions of this compared to competitors is, as I said, with the degassing, because you spend a lot of time as a brewer actually degassing these samples before you can run. And that's quite an advantage we have here. It reduces the time immensely for our customers. The other thing that's really important is the pH, because pH is usually measured in a brewery with a pH meter, and that is calibrated by each of the operators separately. And so you have a quite big operator differentiation between how they calibrate, how often do they change the liquids for the pH meter. But here we remove that completely by just having it measured through the spectra of the FTIR. So we actually get a quite good pH without having the operator influence deviation that you would normally have in a brewery. And these are definitely two of the more exciting elements that we bring to the market within BeerFoss. So this is the BeerFoss GO. Thank you for listening.